In this video, I'll demonstrate the wonders of using Excel to create graphic presentations. I will be showing you how to construct pie charts, bar graphs, frequency polygons, and scatter plots with just a few clicks. And to make it more interesting, I'll be using data from the class survey that you completed last week. As with the previous lecture series on cross tabulations, I've uploaded a copy of the Excel sheet I'm using in this demonstration. Feel free to download the sheet and practice along as you view this video. We'll start with pie charts. These data are here from our class survey and represent the survey item, what type of music do you listen to the most often? And you will notice that these are nominal data, meaning response categories are distinct and unordered. Pie charts are a great way to summarize nominal data. The graphics tool on Excel can be found by clicking in the Insert button, and there are a lot of options for charts, as you can see. If we click on pie charts, you can see that we have two-dimensional pie charts, three-dimensional pie charts, and donut pie charts, which makes me hungry as I think about it, but I digress. To make a pie chart, I'm going to go ahead and highlight the categories along with their frequencies first. Then I'm going to go to the pie chart icon, and I'm going to click on 2D pie. And here we have an actual pie chart. As you can see, all the categories are represented with their relative frequencies in color. And I'm going to do a couple different things first. I'm going to click on the chart title. I'm going to give it a title. Okay, Music in Socio 365, that's our title. And then I can come to these buttons on the right-hand side and I can change my pie chart to fit my needs. So I'm going to click on this button first. I have a chart title now. I can get rid of it if I don't want it, but I do want it. Now I've gotten rid of the title, but there you go. I can center it in a different place, or I have other options I can do, but I like it above the chart. We can add data labels if we want. This is giving the numbers that are actually in each, but we're not going to do that. And then we have a legend at the bottom here, but we can move the legend around if we'd like, to the right, top, left, or we can get rid of the legend altogether, which I don't know why you would do that, but so we're going to keep the legend in this case. The next button down is the style button, and if you click on this, you have some really cool different chart styles that you can choose from. And let's see, there's some that even have the percentages. I can't find it right now. Anyway, you can choose, oh, there's one that has the percentages in it. So you can choose different styles, whatever you feel like you want. There's also different colors that you can choose too. So lots of ways of customizing a chart. When you're finished with the chart and you've got it just the way you'd like it, you can right click on it and copy it and paste it in any Word document. So it's very easy to do. We can also use these same data to create a bar graph. So I'm going to, again, highlight the categories plus their frequencies. I'm going to go to the Insert section. But instead of a pie chart, this time I'm going to go and insert a bar graph. And as you can see, there's different kinds of bar graphs, but we're going to go with a 2D column graph. And here you go. You have the same information that was in the pie graph, but this time it's represented as a bar graph. And I'm going to put a title. And I am going to, I could, if I wanted to, I could add data labels. I could do a couple different things, add error bars. I could add a legend if I wanted, trend line. I'm going to go to the style part where you can choose all different styles for your bar graph. And I think that one's pretty cool. Actually, I don't know if I like the numbers on it though. Anyway. You can play around with it and find a style that fits you. You can change the color of the graph if you'd like. So there's many different ways of customizing the graph to your desire. And once again, when you're done with your graph, you can just copy it and paste it somewhere else. And that is your bar graph. And the next type of chart I'd like to discuss is a frequency polygon. And frequency polygons are used with ordinal and interval data. So we've been working with nominal data here, but we're going to switch over to another survey item from the class survey. And this is the item that asked you about how often you eat healthy foods and exercise regularly. A score of 1 means not very often. A score of 10 means nearly all the time, if not all the time. And so you can see there were scores anywhere from 1 to 10, and the frequencies are right next to them. So one person said they had a score of 10, 6 people gave themselves a score of 4, and so on. We also have a cumulative frequency column that we'll talk about in a little bit. So this is the frequency of health scores from the class survey. To create a frequency polygon, we're going to select the scores and their frequency, go to the Insert button. This time we're going to select Scatter, let's see, right there, a scatter plot with lines. And this will give us a frequency polygon. As you'll notice, it's not a complete polygon because in an actual polygon, the lines have to go down to the very bottom, to the baseline, to make a polygon. But in this case, we'll pretend that they do go all the way down. And this is a way of showing frequencies for ordinal or interval data. And so I want to give it a title first. And when I'm reading a graph or a chart such as this, I really want to know what the axes are. So I'm going to give them some labels. On the x-axis, we have the health score. And on the y-axis, we have a frequency. And as you can see, the data on this chart do match the data that we have over here. For example, we have one person who had a score of 10, and it's right there. Let's see, we have 7 people who had a score of 7. So the data match up just wonderfully, but it gives us a more of a visual way of looking at the data. So we can make decisions about the data sort of based on what we're seeing in the graph. If instead of a frequency polygon, we want to make a cumulative frequency polygon, we can do that too. And the way that we're going to do that is we're going to select the health scores. I'm going to click on Control and hold it down, and I'm going to now select the cumulative frequency scores. All right, I'm going to go back up to the Insert, and I'm going to go to do the same type of thing. And this time, instead of having a frequency polygon, we have a cumulative frequency polygon, which shows how the scores progress based on the level of the score. So, of course, we had 31 people in our sample, and for a score of 10, we see that there are 31 people that had a score of 10 or lower. So we know that this frequency polygon cumulative frequency polygon is representing our data. Let's just take another check. 23 people had a score of 7 or below, and that does match our table as well. So this is just another way of visualizing the data using the cumulative frequency polygon. And finally, we're going to talk about how to construct a scatter plot. And scatter plots are useful when we have 2 variables. So I'm going to click out of this. I'm going to go to our next tab, which is Health and Stress. So on your survey, you answered 2 different questions. One, of course, on the health that we just looked at. You also answered about how stressed out you feel. 1 being not very stressed and 10 being quite stressed. And so what I have here is going to be a little bit different than the last table, in that these are not the frequencies of scores, but rather these are the scores for individuals. So this is person 1 had a health score of 1 and a stress score of 7. Person 2 had a health score of 6 and a stress score of 7. I just want to take a minute to remind you that your names are not connected to this data at all. However, there's an ID number that helps me to be able to put scores together for individuals. So your name is not, I don't know who you are in this survey. And this is just 10 out of the 31. I just grabbed 10 at random just to do this illustration. So for each person out of the 10, the person has a health score and a stress score. So I might have a theory that health choices affect one's stress level. If so, what is the independent variable in my hypothesis? Think about that for a second. Health choices in this case would be the independent variable, and stress would depend on the health choices I make. So this is sort of my hypothesis. To look at two variables together, I'm going to highlight just the scores on the two columns, just the scores. And I'm going to go to a scatter plot, but this time I'm going to construct one without any connecting lines. There we go. And I'm going to do just a little bit of cleaning up to make this title, this chart, easier to read. Okay, I've got my title. I need my axes. Okay, so what each dot represents is the coordinate of someone's health score and their stress score. So for example, this person right here had a health score of 1 and a stress score of 7. And if we go over to our data, we can identify who that person is. Let's see, this person here had a health score of 6 and a stress score of 7. So we see that actually right there as well. So this is just another way of visualizing how the data are organized in a distribution. And so we're going to talk more about this type of scatter plot when we talk about regression and correlation. So this is coming, but I just wanted to give you a heads up about it right now. And I'm going to end with some caution about interpreting graphs. And as I mentioned at the start of the class, one important goal is to avoid being bamboozled by people who throw numbers at you in statistics. And graphs can and have been constructed to favor one position over another. So let's take a look at two mythical political candidates. We're going to start with Chris and Pat. One measure of how well they're doing in their political race is how many new Facebook likes each candidate receives per day. As you can see on the table, candidate Chris averages 3,241 new Facebook likes per day, and candidate Pat averages 3,100 new likes per day. Does that seem like a big difference to you? Well, let's see what the pie graph shows, pie chart. No, I'm going to do a bar graph. Okay, backing up. Insert. I'm going to do a bar graph. Well, that looks like a bigger difference than I thought. It's a little confusing because I don't think of 3,241 and 3,100 being that different. But if I were to just look at this bar graph, it certainly looks like Chris has much more likes than Pat. Is this a good representation of the data? What could be at play here? Take a moment to pause this video and think about it if you don't know already. Okay, the secret is in the axis values. What is the range of possible new likes offered? Well, anywhere from 0 to 3,241. But this graph starts at 3,000. It's showing 3,000 as its bottom value. But so what if we reset the bottom value to 0 to represent the full range of possible scores? Let's do that. I'm going to format the axis. I'm going to make the minimum 0, and I'll keep the maximum at 3,300, close enough. And as you can see, when we use the full range, the bars really don't look dramatically different. If I wanted to convince somebody that I was doing a lot better than I actually was, I might use this other range to show that. So Chris might use this to show popularity. However, the more accurate graph would be the one that shows the full range. And therefore you can see that those scores are actually quite close. Now the same idea can go in the opposite direction as well. So let's take two other candidates, Sam and Robin. I'm going to highlight them and I'm going to insert their bar graph. Okay. So salmon robin, there does really, if you look at the numbers, there does seem to be a difference. 3,800 does seem like a lot more than 2,500, and this actually looks like a reasonable representation of that. And lo and behold, this one does start at 0. But let's say I'm Robin and I want to make it look like there isn't as much of a difference. I can double click and I can format the axis to, let's say we're going to say that there's a possible 20,000 responses. Well, all of a sudden, those differences don't look as extreme. So by manipulating the range, we can manipulate how the bars look, so to speak. And so one thing that some people do also is they might actually get rid of the axis. Let's see. Just one second. There is a way of getting rid of the... Okay, I'm going to make it primary horizontal. No, that was wrong. Primary vertical. There you go. Nope, that's not it either. Well, I'm going to just say that what you can do is actually eliminate these numbers altogether. There you go. That's how you do it. And so I want you to be on the lookout for this, particularly in this political season, that people may be constructing graphs in such a way to make a case that maybe isn't reflective of reality. So the message is not to just look at the shiny colors on a graph, but to look at the values and the numbers on the graphs as well. If you see any such sneaky graphs during this political season, please share them with the class. But for now, I encourage you just to take some time to explore Excel's graphing tools. They can be a lot of fun.